this is Mrs. Blaylock, and I am going to continue with 1.2. We're talking about Objective C, increasing, decreasing, and constant functions. So by the end of this section, you will know the definitions of increasing, decreasing, constant, and you will be able to determine where a function is increasing, decreasing, or constant. So in our book, if you take a look at the definitions, it says a function is increasing on an open interval I for any x1 and x2 in I, where x1 is less than x2, then f of x1 is less than f of x2. We've been talking about domain and we've been talking about range. So when it says increasing, saying that increasing is going to be our descriptor. Increasing, the function is increasing on an open interval. An open interval just is kind of, an interval is giving you a range of values for any x1, and so this is an input, and x2, those are both inputs. Remember, x1 and x2 are inputs. And then it says where the first input is smaller than the second input, then f of x1, that's our output. When you put x1 into the function, whatever you get out is less than the next x that you put in, your next output. So for example, my x1, I might put in 0 first. If 0 is less than the next input, so if x1 is 0 and x2, let's just say x1 is 0 and x2 is 1. x1 is smaller than x2. If when I put in x1, what I get out is smaller than what I put in when I put in x2, then the function is increasing. I think it'll make more sense when we do an example. The next definition says a function is increasing. All right, there was a typo. It should say decreasing. A function is decreasing on an open interval I if for any x1 and x2 in I where x1 is less than x2, meaning you're going to put in a 0, then you're going to put in a 1, then you're going to put in a 2. So x1 is smaller than x2. Your input is going from left to right in the number line. Then f of x1 is greater than f of x2. So in the increasing, your f of x is smaller. Your f of x1 is smaller than your f of x2. But in your decreasing, your f of x1 is bigger than your f of x2. So you're still going from left to right with your input values, but now your value is bigger and then it gets smaller with the next input value. And the third definition is a function is constant on an open interval I if for any x1 and x2 in I where x1 is less than x2, so these again are our inputs, I'm starting left on the number line, then f of x1 equals f of x2. So our outputs don't change. So it's constant if our outputs stay the same. Okay, so in your book, where the definitions are listed, we also have this graph. There's all different parts going on. You've got this line with a negative slope, and then you've got part of a curve, and then it looks like you have a horizontal piece of a line, and then you've got another curve, and you've got another line, and another line. And they give you some ordered pairs that are on the graph. So we've got -2, -2, -1, 1, 0, 1, 2, -2, and 6, 4. So when we're going to talk about functions being increasing, decreasing, or constant, the first thing you're going to do is read from left to right. And the intervals correspond to the x values. That's where those definitions came in, x1, x2. Those are your inputs. Increasing means from left to right, the graph rises. Decreasing means from left to right, the graph falls. Constant means from left to right, the graph stays a constant value. And whenever you describe the intervals, you're going to use interval notation, joining the intervals with that U symbol. So let me just show you a quick little tutorial, and before we come back and decide where this function is increasing or decreasing. So I did a Google search, and I found an applet that shows us increasing or decreasing. And so here it is. So here's a function, and so we're going to look at it from left to right. And there's a little turtle on the graph, and this kind of looks like our parent function cubic. So if I want him to start, I'm going to press start, and then the turtle is going to start going up. So you can see that it's going to change colors. So as from left to right, think about what's happening. So he's traveling from the left side to the right side, so you can see it's getting green on the x-axis. And he went up. He went up the entire way on the function. So the function is increasing because from left to right, he had to go up, the little tortoise. So I'm going to click him again. And as we keep going to the right, he's still going to the right, but this time he had to come down the function. So we would say the function is decreasing in that interval. And then if I click him one more time, he's going to continue to the right. In order to go to the right, he has to go back up. So the function is increasing again. So from A, right here where he started, our x value all the way to right here about, the function was increasing. And then the x value right here, all the way to the right, was increasing again. So we would say the function increased between those two intervals. And then over here, this x value, he had to start coming down the function to the right side. That part of the function was decreasing. So let's go back and take a look at the one from our book. From left to right, if I trace this function, I would say it's from left to right, it's coming down, so it's decreasing. So where did I start? If this is a line that continues on forever, I start talking about decreasing. From left to right, I can go as far left as negative infinity. And then right here, when I stop drawing my line, I have to change direction. So I can no longer keep going down. I'm not decreasing anymore. So I stopped decreasing at -2. And we can say it's included or not included. It's a closed circle, but it's not clear which one it is a part of, the red or the blue. So now I'm going to continue going to the right, and I'm going to follow from -2, I'm going to follow the curve here. And I start going to the right, and in order to go to the right, I have to go up. So I'm increasing. I started at -2, and I stopped at x equals -1. So from left to right, I started at -2, and I went to -1, and that's where I was increasing. Now let's see what happens. From -1, my x value -1, if I continue going to the right, I stay flat, so that's remaining constant. So from -1 to 0 in my x values, -1 to 0 in my x values, I remained constant. Now if I continue to follow the function, so I'm starting at 0, 1, and if I am pretending to be the tortoise and I ride the function from left to right, I'm going down again, so this interval is decreasing. So I started my x value of 0, and I went to my x value of 2. So over on the decreasing part, I'm going to make a union from 0 to 2. I was also decreasing. Then from 2, I continue like the tortoise riding the function. I go all the way up until 6. So I'm increasing. So I'm going to make another union. Sorry, this is not really calibrated. From 2 to 6. So I'll fix that for you. Okay, so then if I continue on the function from left to right, I'm at x equals 6, and I ride that like the tortoise, ride the function on down, I'm decreasing. So from 6 until it keeps on going, from 6 until infinity, it's decreasing. So my intervals, if I'm going to describe the function, if I was asked, where is the function increasing, decreasing, and remaining constant? The function is increasing from -2 to 1, and then also from 2 to 6. So if I go from left to right, where is it decreasing? It's going from negative infinity to -2, and it's also going from 0 to 2, and it's also going from 6 to infinity. And then the only part where it's constant is from -1 to 0. Just remember, the parts you're describing are your x values. So if you want to determine if a function is even, odd, or neither, you could do that first, and then we can also take that same graph and say, hey, is it increasing or is it decreasing? So take a look at this picture, see what you think, and pause the video, and I'm going to put the answers up while you're thinking. Okay, so I hope you have your answers. So here's the big reveal. From left to right, from negative infinity to -3, it's increasing. So I'll trace that for you. Down here, -3, it's increasing, and then it also is increasing over here from 1 to 4. Decreasing, it's decreasing from -3, so that's -3 about. It's decreasing all the way until 1, and it remains constant on this upper right part over here from 4 to infinity. So that's it. That's Miss Blaylock.